Yeah, hello student, good morning everyone. Today we are going to see comparison of the different topics. Okay, so first we are going to do with comparison of kinematics and rotation motion. Okay, we are going to compare each and everything. It's a quick review for the NEET exam. Okay, so first we will be doing with one by one. Yeah, so this side is a linear motion. It's a very important review. Okay, if you are listening 1 hour means you are able to thorough with many formulas from 5 chapters. Okay, it is 11th as well as 12th. Okay, mostly important formulas we are going to discuss, like a comparison. It's a one chapter versus another chapter. Okay, so first we'll take it as a linear motion. Each and everything we are going to discuss. Okay, linear motion. The another side is the rotational motion. So then we are going to see with gravitation and electrostatic comparison, and also magnetism and electrostatic comparison. Okay, this what we are going to do. Okay, so one side is the linear motion, the another area it's going to be the rotation motion. Both we are going to have the comparison, full comparison. Okay, instead of studying full chapter, if you are listening my class means easily you will come to know most of the concept. Okay, it's like a quick and fast warm-up revision. Okay, so now first one, linear motion. In linear motion, the object is moved from one point to another point. We will take it as the displacement. Okay, otherwise distance. Okay, so unit of displacement we are taken as the meter. Okay, unit of displacement we can take it as a meter. So dimensional formula, it is a SI unit. Always you should follow as a MK system, meter kilogram second. Dimensional formula m power 0, L power 1, T power 0. There is no time. Okay, in rotation motion, same thing, the object is moving in a circular motion. Okay, rotation motion. So angular displacement we can take it as a theta. Okay, so the unit of theta is going to be the radian. The unit of theta is going to be the radian. Okay, dimensional formula for angular displacement m power 1, L power 1, T power 0. There is no dimensional formula for the radian. Okay, in case theta you can take it as a degree also when you are doing the problem. So convert as a radian, then only the problem it will be correct. Okay, the next one, linear velocity. One side is a linear motion, another side is a rotation motion. Linear velocity is going to be displacement by time. Parallelly you should know which is scalar quantity, which is vector quantity. Okay, displacement is the vector quantity. Displacement is the vector quantity. Angular displacement is going to be the scalar quantity. Okay, again the velocity is the displacement by time. So displacement we can take it as a meter, time we can take it as a second. Okay, if you are taken second from denominator to numerator, meter second minus 1. If you want dimensional formula, mass m power 0, length power 1, time power minus 1. Okay, so because m is the meter, length we can dimensional formula. If you want to know meter, you have to take it as L, kg you should take it as m, second you should take it as t. Okay, so here there is no mass, power is 0. Length is there, power plus 1. Time is there, power minus 1. Okay, one side is over, linear motion. Same formula for rotation motion, omega we can take it angular velocity. Angular velocity is going to be angular displacement by time. Angular displacement by time. So we can take it as the angular displacement is the radian. Time is the second. Okay, from denominator second, if you are taken as numerator, radian second minus 1. Okay, if you want dimensional formula, m power 0, mass is not there, length is not there, only time is there, t power minus 1. Okay, the next one, angular velocity, it's an acceleration. All A we can take it as acceleration. Acceleration is going to be the, it is velocity by time. Okay, the another formula I want to tell you, velocity we can take it as a rate of change of displacement. Okay, like this also we can take it. Okay, acceleration is equal to rate of change of velocity. Again, if you are substituting velocity as this much means d square by dt square, it's going to be the displacement in the form of displacement. Acceleration is velocity by time. Simply we can take it velocity by time. That's going to be the rate of change of velocity per unit time. Okay. So same way, if you want here, angular acceleration is equal to angular velocity by time. Same equation you can write, alpha is equal to d square omega by dt square. Also we can write it's going to be the angular acceleration. Okay, one side is the linear motion, another side one is the rotation motion. Okay, now we are going to discuss how the neat question asked here. Okay, some equation they will be given. Okay, so example, x is equal to 2t square plus 3t plus 3, like this is given. Okay, they will ask you from displacement to the acceleration. Okay, if you are differentiating one time displacement per unit time, we will get as a velocity. Okay, one time if you are differentiating this equation, we will get as a velocity. Okay, that's going to be 2 into 2t 2 minus 1 plus 3 into 1 t power 1 minus 1 plus constant differentiation will be 0. Okay, so differentiation equation t power n, it's n t n minus 1, like this you have to follow the formula. Okay, so I once I differentiated with the displacement, I'll get what is a velocity. So dx by dt I can get 4t plus 3t 3t power 0. Okay, 3t power 0 we can take it as a 1 also. So velocity if you want 4t. Okay, so again if you are differentiating this equation, you will get acceleration. Acceleration is equal to rate of change of velocity, that's going to be 4 meter per second square. Okay, next, at this side also same condition we can use. The next comparison. Okay, so just we are going to have the comparison between linear motion and rotation motion. Okay, linear motion we are going to take it as the mass unit is going to be the kg. Okay, a dimensional formula, m power 1 mass power 1 length, there is no length, there is no time, power 0 will get. Okay, same thing in rotation motion. You want to mass means mass is going to be inertia here. Okay, mass into radius square, r is called radius of gyration. Okay, if you want this SI unit, mass is kg, distance is meter, meter square we can get. Okay, dimensional formula for this, m power 1 l power 2 t power 0, there is no time here. Okay, so in linear motion if you are taken as mass means rotation motion, take it the same thing is in a it is inertia. Okay, now next one, momentum, this side is mass into velocity. Okay, mass is kg, velocity is meter per second, so kg meter second minus 1. Okay, finally if you will get dimensional formula, m power 1 l power 1 t power minus 1. Okay, same thing if you want in rotation motion, it's angular momentum. Angular momentum is equal to linear momentum times of radius. Okay, linear momentum we know mass into velocity into radius. Okay, so mass is kg, velocity is meter per second, radius is meter, so kg meter square second inverse, kg meter square second minus 1. Dimensional formula for angular momentum, m power 1 l power 2 t power minus 1. So this is the final dimensional formula for angular momentum. Okay, next, force. This side in linear motion we can take it as the force. Force is equal to mass into acceleration. So mass we can take it as a kg, acceleration we can take it as a meter by second square, because acceleration is velocity by time. From denominator if you are taken as second as numerator, kg meter second minus 2. If you want dimensional formula for this, m power 1 l power 1 t power minus 2. Same thing, same formula if you want in rotation motion, means torque. Torque is equal to force into perpendicular distance. Okay, when you are doing the numericals, do perpendicular distance into force. This is the wrong formula. You have to take it radius into force. Okay, same thing, angular momentum also you can take it as the r into p. Don't take it as a p into r. Okay, now this unit, okay, radius is meter, force is newton. Newton meter also we can take it newton kg meter second minus 2. Okay, so torque will get it is going to be meter kg, usually you have to write with kg meter square second minus 2. If you want dimensional formula for this, m power 1 l power 2 t power minus 2. Okay, so now comparison of force. When you are calling force in a linear motion, means in rotation motion, the same equivalent unit you can call as the torque. Okay, the next one, energy, I am going to do it. Okay, this side will be the energy. Energy unit is going to be, lot of unit is there, will be taken as the joules. Energy is equal to force into displacement for linear motion. Force is Newton, displacement is meter, or we can call both together as the joules. Okay, so we can write kg as a meters, kg meter second minus 2 into meter. Okay, like this we can write meter square. So kg meter square second minus 2, dimensional formula m power 1 l power 2 t power minus 2. Like this you can write as the dimensional formula. Same equivalent thing in energy in rotation motion. Energy in rotation motion, torque into displacement, because force we can take it as a torque in rotation motion, displacement we can take it as an angular displacement, theta. We should take it here, it is a theta. Okay, torque already we know, it's force into displacement into theta. So f for theta, f it's going to be torque d theta, also we can say as the energy. Okay, in rotation motion, torque into angular displacement, it's going to be the theta. Okay, now here torque is Newton meter, theta will be the radian. This is the unit of torque, unit of energy in a rotation motion. Okay, so same equivalent unit kg meter second minus 2 Newton meter radian. Okay, meter we can write as a meter square. So kg meter square second minus 2 radian. If you want dimensional formula, m power 1 l power 2 t power minus 2. Dimensional formula also I got for the energy in a rotation motion. Okay, the next one, power. Power is equal to energy by time. So energy by time, energy we know it's going to be force into perpendicular distance, okay, divided by time. Distance by time we can take it as a velocity. So power not only energy by time, force into velocity also it's going to be the energy. Okay, same thing if you want in rotation motion, energy is equal to, power is equal to energy per unit time. So energy is here, it's going to be torque into d theta divided by dt. So this is going to be the angular velocity. Same equivalent unit for rotation motion, power is equal to torque times of omega. So equivalent unit of power. Okay, the next thing, scalar and vector quantity also you should know. Okay, work done is equal to actually f s cos theta. It is dot product. Whenever cos theta is there, that's going to be the dot product. Both is a vector quantity. When you are doing product of two vector, so work done, it's going to be the scalar with the representation of cos theta. Whenever cos theta is there, you have to take it, that product of this going to be the scalar quantity. Okay, again this side work done is also, it's going to be torque times of angular displacement with cos theta will come. Okay, so now power is equal to fs cos theta divided by time period. So power formula will become as a fp cos theta. Okay, wherever you are getting as a cos theta, you can take it that as a scalar quantity. Okay, in formula if you are getting cos theta means you can take it as whether it's 11th standard or 12th standard, you can take it as that's the scalar quantity. Okay, next, how we can convert from radian to the degree to the radian. Okay, it's very simple logic. Degree to the radian, definitely it's required when you are doing the rotation motion problem. Okay, so whenever I got it is, in case I got 180 degree is equal to dash radian. So 180 degree is going to be, it's very simple, 3.14 radian. Okay, same pi is equal to 3.14 radian. Okay, if you want 1 degree is equal to how much radian? It's going to be 3.14 radian divided by 180. The answer we are going to get as the 0.0017 radian. Okay, so that also can be happen. You have to do, don't do with the problem in a degree. Okay, we'll do the problem always in a radian. Okay, again if you want the conversion with the radian to the degree, opposite way you should do 180 degree as a 3.14 radian. Okay, that's going to be, pi is going to be 3.14 radian. So 1 radian is equal to it is 180 degree divided by 3.14. That much degree we will get. Approximately we will get 1 radian is equal to it is 57 degree and something 3 you will get. Okay, so this is a logic definitely you required when you are doing the rotation motion problem. Okay, in case they are given a 54 degree is equal to dash radian. Okay, so 54 degree already I know 1 degree is how many radian? Okay, it's going to be 0.0 0.17 radian. Okay, like that easily you can do the calculation. Okay, now the next comparison, equation of motion. Okay, so from linear motion to rotation motion I'm going to do with the equation of motion. Here v is equal to u plus at. Okay, equation of motion, s is equal to ut plus of at square. Again v square is equal to u square plus 2as. Okay, here u is the initial velocity, v is the final velocity, a is the acceleration, and t is the time period. Okay, if you want equivalent equation in rotation motion, means omega is the final angular velocity is equal to omega naught plus alpha t. Okay, same, it's s is going to be theta. Here theta is equal to omega naught t plus of alpha t square. Okay, same equivalent equation, omega square is equal to omega naught square plus 2 alpha theta, like that you can say. Okay, so see here I'll give the comparison. V here it's going to be the omega rotation motion, u is going to be the omega naught, u is going to be the omega naught. Okay, so a is going to be the alpha here, a is going to be alpha here. Okay, s is going to be the displacement, here it's going to be the theta. Okay, like a direct comparison, you no need to memorize. If you are listening this easily, you are able to do with you can recall many of the formulas. Okay, time will be same here and there. Okay, so we already given three equation of motion. The fourth equation of motion, it's already they asked previous year question, neat question also based on this problem. Displacement for nth second is equal to u plus of a 2n minus 1. It is the displacement for nth second. Okay, it's very important formula. The same equivalent formula if you want in rotation motion, means theta for the nth second, angular rotation for the nth second is equal to angular velocity plus half times of alpha 2n minus 1. So the same equivalent equation we have to write in a rotation motion also. Okay, just like a comparison. So here we have kinetic energy is equal to of mv square. Okay, same equivalent equation if you want in rotation motion, means kinetic energy of will be same mass. Already I told you in rotation motion inertia, velocity we can take it as the omega, so omega square. Okay, like this we'll get, so of I omega square in rotation motion. So we can have the energy like this. Okay, in linear motion we can have kinetic energy like this. Okay, so now we learned all basic conversions. Some small relation we are going to do with the relation between linear and rotation motion. Okay, so I have the circular motion. Okay, so we are taken as the arc length. Okay, yes, theta we are taken as the theta. Okay, and radius r we are taken. If you want angle, theta is equal to it is s by r, arc length by radius. Okay, if you want proof for full complete circle, arc length is going to be the circumference of the circle, 2 pi r. Okay, so 2 pi r divided by r get cancelled, only 2 pi 360 degree, that's going to be not a 360 degree, 2 into 3.14 radian. Okay, like that also you can give. So now theta is equal to s by r, that is one of the main relation. Okay, already you know what is theta, angular displacement. What is s? It is the linear displacement. R is the radius of the circle. Okay, so s is equal to theta times of r. Okay, so some common important relation we are going to discuss from linear motion and rotation motion. If you are differentiating the above equation, ds by dt, differentiation means with respect to the time, d theta by dt into r, just time differentiating. Displacement by time, which is going to be called as a linear velocity, angular displacement by time, which we are taking as angular velocity, into r. This is another relation, v is equal to omega times of r. It's required when you are preparing for the NEET. Okay, so again with respect to the time I am differentiating dv by dt. Okay, you no need to memorize a lot of formulas. If you know how to do with the simple logic, means easily you can recall all the formulas. Okay, rate of change of velocity with respect to the time, it's an acceleration. Acceleration is equal to angular acceleration times of radius. Okay, this also one more relation we have. Okay, so there are three relations I'm given. Theta is equal to s is equal to theta times of r, v is equal to omega times of r, a is equal to alpha times of r. This is the main relation, linear motion and rotation motion. Okay, just the next one, time period is equal to 1 by frequency, or frequency is equal to 1 by time period. Some of the time frequency they will be taken as a n. Okay, so now omega versus n, omega versus angular velocity versus frequency. Okay, angular velocity is equal to angular displacement by time period. Okay, so angular displacement for full complete circle theta is going to be 2 pi. 1 by time period we can take it as a frequency. So omega is equal to 2 pi f. Okay, this is another relation in rotation motion you have to keep it in your mind. This small relation and all, it help you to do the lot of numericals. Okay, neat. Most of the problem will be asked in direct way, not in indirect way. Okay, the next one I'm going to prove you L is equal to I omega. Angular momentum is equal to omega times of inertia. Okay, this formula also you should keep L is equal to P times of R, P is equal to MVR, V is equal to omega R. So V is omega R into R. So MR square is equal to MR square into omega. Easily within a second you can get this formula. L is equal to I times of omega. Okay. The next one, torque is equal to I alpha. Torque is equal to I alpha. This equation also we are going to prove. This small relation will do with the if it's help you to do the problem. Torque is equal to force into perpendicular distance. Okay, so force is mass into acceleration. Perpendicular distance is the r. Okay, I know already A is equal to alpha times of r into r. So mr square it's going to be alpha. This everything we can call inertia. I alpha is going to be the torque. Okay, torque is equal to I alpha. Torque is equal to I alpha. That also I will keep it in the mind. Okay, the next one, it is dl by dt is equal to rate of change of angular momentum is equal to torque. So very important relation. Okay, it's a most important relation. Okay, I know torque is equal to L is equal to I omega. If you are differentiating this equation with respect to the time, dl by dt is equal to I d omega by dt. So what we can take it, this everything rate of change of angular momentum, but this going to be the alpha. Okay, I alpha is equal to dl by dt. Okay, so I alpha already I know it's going to be the torque. So dl by dt is equal to torque. It's most important formula in the rotation motion. Whenever torque is getting zero, okay, so if you are going to differentiate dl by dt is equal to 0, when once if you are in doing like this means the L value is going to become as a constant. Don't give L value is the 0. When you are differentiating as a 0 or integrating as a 0, it's going to become as the constant. So angular momentum is going to be the conserved. Okay, conservation of angular momentum. Okay, so not only angular momentum is conserved, we know previously momentum P is conserved. Conservation of momentum. Okay, E is conserved. Energy is conserved. Okay, energy is conserved. And mass is the constant. This and all very basic terms you need to know. Okay, so conservation, neither be create nor be destroyed. Energy neither be create nor be destroyed. Momentum neither be create nor be destroyed. The same way angular momentum neither be create nor be destroyed. Okay, so angular momentum also become constant here, conserved here. Okay, so energy mass relation, energy and mass, it's going to be the equivalence. Okay, once energy will be converted as a mass is going to convert as a energy. That's also going to happen. This and all small information you have to keep it in your mind to have the knowledge of relating with one concept with another. Okay, now so most of the relations I'm given linear motion versus rotation motion. Okay, then some more relations. One more relation is there, centripetal force. Centripetal force F is equal to mv square by r. Not only this formula, we have another formula also. Why sir we are giving this many formulas? Okay, if you are know only formulas, then only you are able to do with your neat questions. Okay, v is equal to omega times of r. Already I told you how I got this one. Omega square times of r square divided by r. This get cancelled. So I will get the another formula, f is equal to m omega square times of r. Otherwise f is equal to ma, no. Now acceleration is not only v square by r, it's going to be the centripetal acceleration, which is also called omega square times of r. This also can be possible in a rotation motion. Okay, so now don't stuck with only one formula. You relate with some other place also to get with the different formulas. This then only it will be save your time to proceeding the problem. Okay, next I'm going to do with another comparison. Okay, so the another comparison I'm going to take it as a electrostatic versus gravitation. Okay, then we are going to compare with magnetism versus gravitation. Okay, the next comparison I'm going to do with electrostatic versus gravitation. Okay, so when you are learning this, it will be very easily you can remember all the formulas. So next half of the class we are going to do with electrostatic versus gravitation. Just a minute, within 1 or 2 minutes we'll start the class. Yeah, now we are going to discuss with electrostatic versus gravitation. Okay, so this is a very quick revision and also a very simple technique to memorize all the formulas. Okay, you no need to do the concept. Without doing the concept, easily you will come to know all the formulas. Okay, from these formulas many of the question they asked from the neet. Okay, the problem how to take the formula, how to memorize the formula, how I am going to bring in the same formula in the actual exam. Okay, so actually you need to save your time, then only you are able to get the good score in your neet exam. Okay, so now I'll be doing a simple trick to compare electrostatic versus gravitation. Okay, both the formulas comparison, it's very simple logic only is there. So if you are listening, you can come to know many of the formulas easily without memorizing. You can get all the formulas. Okay. So now electrostatic. So Q is the charge. I am taken Q is the charge. Charge unit is going to be the coulombs. Okay. Same dimensional formula if you want. Charge we don't have dimensional formula. It's current. We can take it charge as charge is equal to current is equal to charge by time, charge is equal to current into time. So if you want dimensional formula, no need to write as a charge, so it is ampere into second, like that you can write. So m power 0, l power 0, t power 1, a power 1. So charge no need to write as the dimensional formula, you have to write as the current and time. Okay, like that you can relate. Okay, this side for gravitation it's going to be the mass. Okay, so m is going to be the mass, unit of mass is going to be the kg. Okay, dimensional formula m power 1, l power 0, t power 0. Okay, just a basic comparison. Okay, in electrostatic Coulomb's law we can take it, f is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square, the force of attraction or repulsion between the two charges. I have two charges, plus here minus here. So force of attraction or repulsion between the two charges. Here attraction also will be there, here repulsion also will be there. Okay, but when we are coming to the universal law of gravitation, it's going to be the g. Okay, f is equal to constant is going to be g m1 into m2 divided by r square. Okay, now for this one only for attraction will be there, here attraction and repulsion both will be there. Okay, now next what we are going to do is see this side constant is going to be the 1 divided by 4 pi epsilon naught. Okay, here constant is going to be the g. Okay, so the next here constant is going to be a 1 divided by 4 pi epsilon naught 9 into 10 power 9. Here constant is going to be 6.67 into 10 power minus 11. Sometime you need to memorize some constant also, otherwise approximately you need to know the value to do the problem. Okay, now epsilon naught is a unit, here g is a unit, and a dimensional formula, that's also we need to know. Okay, first we will find epsilon naught. F is equal to mu naught divided by 1 divided by 4 pi epsilon naught q1 q2 divided by r square. I am finding this one. Okay, take this one that side, this one this side. Okay, so epsilon naught is equal to charge q1 q2 divided by 4 pi f times of r square. Now what is the charge? Charge unit we can take it as coulombs. Coulombs into coulombs. Okay, force unit is Newton, distance unit is meter square. Okay, for 4 pi it's a constant, there is no unit for it, epsilon naught. So Coulomb square, from denominator this I am taking as numerator. So Newton inverse meter minus 2. Okay, so that is called epsilon naught. So this is a unit. Okay, this is a unit. You can give the same unit as a epsilon naught value. Now dimensional formula if you want means you have to do some more extra calculation. So I know coulombs is equal to ampere into second. Before only I said. Okay, so coulombs we can write ampere into second. This is square Newton inverse meter minus 2. So now ampere square second square. Okay, because of whole square. What is Newton? Newton is a force unit. Kg meter second minus 2 meter Newton inverse meter minus 2. Okay, just simplifying the formulas. Okay, ampere square second square kg inverse meter inverse second plus 2. Okay, meter minus 2. So now all together we are making, so kg inverse first one, meter minus 1 minus 2 minus 3 we have, second plus 2 plus 2 plus 4 we have. Okay, ampere square, that the final dimensional formula for permittivity is permeability is going to be m power 1 l power minus 3 t power plus 4 a square. Okay, this is the final dimensional formula for the permittivity. On this side we have another side, the same capital G as the constant here, universal law of gravitation. So F is equal to G times of m1 m2 divided by d square. Okay, here the only force of attraction, m1 mass and m2 mass. Okay, distance will be d or r, whatever you want you can take it. Okay, if you want G as the subject, remaining everything you can take it as a one size. Okay, m1 m2. Now what is F? Force is the Newton. G unit we are going to find. Newton meter square divided by kg into kg square. From denominator if you are taken as kg as a numerator, kg minus 2. So Newton meter square kg minus 2. What is Newton? Newton we can take it as kg meter second minus 2 into meter square kg minus 2. Like this we can take it. Now what we can do is, here plus 1, here minus 2. So kg minus 1 meter cube second minus 2, which is a capital G. Universal gravitation constant is the unit. Dimensional formula now, m power minus 1, l power 3, t power minus 2. I'll see again what I did is correct or wrong. Okay, it's the minus 1, 2, yeah, correct. It's going to be correct. Okay, so now capital G dimensional formula we saw. Next, this side is gravitation, this side is electrostatic. Okay, next, this side electric field. Electric field is electric force per unit charge. Okay, the same thing. Gravitational field. Gravitational field. It's Coulomb's force. Universal law of gravitation force divided by mass. Okay, see the difference here. Charge plays major role. Here mass plays major role. E is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square divided by q. Q get cancelled. 1 q get cancelled. So electric field formula 1 divided by 4 pi epsilon naught q divided by r square. Same if you want gravitational field. Gravitational field, it's going to be g times of m divided by r d square or r square, whatever you want you can take it. Okay, so simplification, f is equal to g times of m1 m2 divided by r square divided by m get cancelled. This is what we can get, d square or r square, whatever you want you can take it as the distance. Okay, The next one, electrostatic potential energy. One side is electrostatic potential energy. Another side, gravitational potential energy. Potential energy is equal to force into displacement. We can take it simply, energy is the force into displacement. Force, we are going to take it 1 divided by 4 pi epsilon naught q1 q2 divided by r square. Okay, it is for it's electrostatic. Just a minute. In electrostatic, the force we can take it as it is Coulomb's force. Okay, already we know the force of attraction or repulsion between the two charges. What is the formula for it? Okay, when the distance I multiplied according to the dimension, one distance has to go. Okay, so into r, distance will get cancelled. Energy is going to be 1 divided by 4 pi epsilon naught q divided by r. Okay, this side, gravitational potential energy, when the energy comes, use as a negative symbol because of external force. So directly you can use as a negative symbol. Here energy, gravitational potential energy, force into displacement. So force, I know it's going to be g times of m1 m2 divided by d square into d. So dd get cancelled, one power will get cancelled. Gravitational potential energy minus g m1 m2 divided by d. It's going to be the gravitational potential energy. This is going to be the electrostatic potential energy, Q1, Q2 divided by R, electrostatic potential energy. Next, gravitational potential, it's going to be the EV. Potential is work done per unit charge. Okay, work done already we found, energy only work done. So electrostatic potential minus 1 divided by 4 pi epsilon naught Q1, Q2 divided by R divided by Q. So Q get cancelled. So electrostatic potential minus 1 divided by 4 pi epsilon naught q divided by r. Gravitational potential, what about gravitational potential? Is going to be minus g m1 m2 divided by r divided by m. I hope you understand. Gravitational potential V is equal to work done by mass. Here whatever we are doing by work done by charge, no, the same thing here we have to do by mass. Mass will get cancelled. So gravitational potential will be minus g times of m divided by r. It's very simple logic. Okay, so it is a main comparison with both the concept. Okay, so it's a main comparison between both the formulas. Okay, so now some simple comparison. Electrostatic we can call as a P. Okay, the same formula, momentum, electric dipole momentum. Okay, magnetic dipole moment we can call as the small m. Okay, here dipole moment is equal to 2L into Q. Q here it's called charge. Here magnetic dipole moment is equal to 2L into pole strength. Okay, pole strength. North pole and south pole strength. Okay, the next one here, torque is equal to EP sin theta. Okay, the same thing in magnetism. If you want, torque is equal to Bm sin theta. B is called magnetic field. Okay, E is called electric field. P is called dipole moment. M is called magnetic dipole. Okay, the next one, torque I got. Electrostatic potential energy U is equal to minus EP cos theta. Okay, the same equivalent formula you will get, U is equal to minus a Bm cos theta. Whenever you got cos theta, you can take it that as a scalar quantity. Okay, this is scalar quantity. Whenever you got sin theta, that's going to be the vector quantity. This is going to be the vector quantity. Okay, the next thing, electrostatic electric field due to the electric dipole at an axial line. Okay, axial line. This and all in 12th standard we learned. It's a very important question. Okay, 2p divided by 4 pi epsilon naught times of r cube. Okay, same thing for equatorial line. It's p divided by 4 pi epsilon naught r cube. Simply you will get. Okay, if you want ratio between these two, 1 is to 2 is to 1. Next, this side, magnetic field due to the axial line. Okay, axial line means end on side. equatorial line board-on side. Okay, 2m divided by 4 pi epsilon naught. Sorry, the magnetic field formula totally will get changed, okay, according to the magnetic field, but similar only. So we'll have B is equal to B at axial line is equal to 2 times of m, 2 times of small m divided by mu naught 4 pi. Okay, same magnetism formula r cube. Okay, next, same, if you want equatorial line, is going to be m mu naught divided by 4 pi r cube. Okay, if you want ratio for this also is going to be 2:1. Thank you for watching my video. If you like my channel, please subscribe and also follow my page. Okay, whenever I'm free, I'll give the like a frequent notes. Before neet, I'll give overall full revision. Okay, if you want 2019 and 20 question paper means, please you go and see my playlist. I solved both the question paper, each and all every question in physics. Okay, thank you everyone.